Hello everyone. Last class I have explained about refraction of light, cause of refraction, then refractive index and few more examples. Today I am going to explain about refraction through glass surface. So what is rectangular glass? Say this is one rectangular glass. Say A, B, C, D. So here this is AB surface is parallel to CD surface. Whenever any light ray will come and strike on AB surface, so one time refraction occurs at this surface, then they will go through the glass, and again one time refraction occurs to the CD surface, then it will come out to the air. So that we are going to learn today. Let's see. This is about AB. Our topic is refraction through glass slab. Refraction through glass slab. Here is one practical is also given. We are going to do practical in our next class. So this is one rectangular glass slab, I suppose. A, B, C, D, where AB surface is parallel to CD surface. Say any ray coming from air medium. This is medium air, this is glass, and this is again air. So AB surface separates air and the glass medium. Similarly, CD surface separates glass and the air medium. Say I am considering one ray coming from air strikes AB surface. Then speed of light will change because medium changes. As the light is coming from lighter medium to denser medium, therefore they will bend towards the normal. From here to here there is no change in medium, so light will go straight. Again at this surface of separation, the light comes from denser medium to lighter medium, therefore they will bend away from the normal. So therefore P, Q, R, S is the complete path of ray of light through glass slab. So this ray is called incident ray. This ray is called refracted ray. This ray is called emergent ray. So this angle between incident ray is called angle of incidence. This is called angle of refraction. And for this surface, this will be the angle of refraction, incidence for the second surface, and this will be the angle of emergence. Now, if we produce the incident ray backward, then we will find that incident ray is parallel to emergent ray. This perpendicular distance between incident ray and the emergent ray is called lateral displacement. Lateral displacement. Now we are going to apply Snell's law. I think last class I have explained about Snell's law. What is Snell's law? Please recall once. Snell's law is sin I by sin R is equal to constant, and this constant is said to be what? Refractive index of second medium with respect to first. So we are going to apply Snell's law. Apply Snell's law for AB surface. We get the sin of I by sin of R is equal to refractive index of second medium is glass. So I will write here refractive index of glass with respect to air. And for surface CD, get sin of, for this surface this will be the angle of incidence, this will be the angle of refraction, sin of R equal divided by sin of E equal to refractive index of second medium with respect to first, A with respect to glass. This is 1, this is 2. Now we are going to multiply equation 1 and 2. 1 multiplied by 2 we will get left hand side sin of I by sin of R, sin of R by sine of E equal to refractive index of glass with respect to air, air with respect to glass. Or you can write, it is reciprocal if I write this one by this one cancel out, so we will having 1. Or you can write sine of I equal to sine of I. Or you can write angle I equal to angle E. Angle I equal to angle E. That means the angle of incidence equal to angle of emergence. Therefore, we find that PQ is parallel to RS. Therefore, incident ray is always parallel to emergent ray. Why? Because AB surface is parallel to CD surface. Moreover, we have proved angle I equal to angle E. So, this is one clue given in your exam. It may come. So, please remember this one. Then, next, we are going to see on what factors the lateral displacement depends. What is lateral displacement? Lateral displacement. The perpendicular distance between incident ray and emergent ray is called lateral displacement. And lateral displacement depends on number 1, angle of incidence, number 2, thickness of the glass slab, number 3, material of the medium, and number 4, wavelength of light. So these are the factors on which lateral displacement depends. So next we will do one or two very small application. Let's say that, say this is one question. So this is a glass slab. If any ray falls normally on the glass slab, what would happen? Then you can plot here the angle of incidence equal to what? 0. And then we already have found that if a ray falls normally, then ray will go straight. There will be no refraction of light. Therefore, angle of R is also 0 degree, and there will be no refraction of light. Then one more formula we have for glass slab. Say if we place the glass slab in any letters, we find that letter seems to raised. So how does it happen? Say this is one glass slab which is placed on any letter. Suppose this is a small letter printed on your book. Then from this letter, suppose one ray falls normally, then this ray will suffer no refraction of light. One ray falls obliquely, then rays coming from glass to air, therefore will denser to lighter medium, they will bend away from the normal. So this refracted ray and this refracted ray, if you produce them back, then they will appear to be at this point. So therefore, if this will be your letter, then this object seems to be raised to position I. If you keep your position here, then you could see the letter at this position. So this depth is called real depth, real depth, and this depth, this one is called apparent depth. Apparent depth. So we have one formula, that this formula derivation is not required for you. You will get it in higher class, but still remember the formula: real depth by apparent depth. Apparent depth is equal to refractive index of glass with respect to air. If it is glass, then glass. If it is water, then water. That means refractive index. So this is one important relation. Please remember this relation to solve numerical. Then we have next, we are going to do one application based on this formula. Say question: when a glass cube of side 6 cm is placed on a printed page, the letter letters appear at a distance of 4 cm from the top surface. Of the cube. Find refractive index. Please note down the question. Then see now here, when a glass cube, suppose I have taken a glass slab, same thing, then it will be of depth of 6 cm, and then the letters appears to raise to a distance of 4 cm from the top. That means this distance is now 4 cm. So we know the formula. Now we are going to use the formula: real depth by apparent depth equal to refractive index. What is real depth here? Given to be 6 cm, and what will be the apparent depth? It is given to be 4. So 6 by 4, then we will do 1.25. So what will be the, this is therefore refractive index is equal to 1.25. Is it clear to you? Okay. In that way you can do certain numericals. Next we will start with length. Few terms. What is length? Next we have lens. It is a transparent medium bounded by two spherical surfaces. Say lenses are of two types. So types of lens. Number one, this is the convex lens, and number two, concave lens. What is convex lens? Convex lens is a lens which the middle portion is thicker than the edge, and here middle portion is thinner than the edge. There are few more lenses, but it is not included in your syllabus, so we are not going to discuss about that. Mainly you have convex lens and concave lens in your syllabus. We are going to discuss few terms related to lens. Say terms related to lens. Number one, midpoint of the lens is called optical center. Then first one is optical center. It is represented by O. The midpoint midpoint of the lens is called optical center. Then next we have, as the lens has two spherical surfaces, so it will be a two sphere. The center of the sphere of which the lens is a part is called center of curvature. So here we have two center of curvature. Next, center of curvature. So definition is same as mirror. So I am not going to write the definition. So I will repeat one more time. What is center of curvature? The center of the sphere of which the lens is a part is called center of curvature. Here it is C1 and C2 are the center of curvature. Next we have principal axis. Principal axis. The line passing through center of curvatures and the optical center is called principal axis. So I mark it here XY. So XY is the principal axis. Next important term is principal focus. Principal focus. What is principal focus? Lens is transparent. You can keep object this side or this side. Rays will come through the lens. So therefore, suppose these are the rays coming parallel to the principal axis. So after refraction, these rays will converge at one point on the principal axis. That point is called focus. So what is focus? The light rays coming parallel to the principal axis after refraction from convex lens. It converges at one point on the principal axis. So that point is called principal focus. And here focus is a real focus. And for concave lens, say this one will be your figure. So these are the rays coming parallel to the principal axis. So after refraction, the ray will diverge. If these rays are going to draw on this side, it won't meet. We'll produce them back. Then they will appear to meet at this point. So this point is called focus. Here the focus is virtual focus. So now the definition of principal focus, I can repeat one more time. Light rays coming parallel to the principal axis after refraction by lens, it converges at one point or appear to diverge from one point is called principal focus. And next we have another important, that is about focal length. What is focal length? It is represented by small f and focus is represented by capital F. The distance between optical center and the focus is called focal length. Similarly here, it will be the focal length. So this lens is also known as converging lens. This lens is also known as diverging lens. Here the focus is positive because the measurement will be taken from O, similar to that direction of the light rays. So this F will be positive and for this lens F will be negative. So next class I am going to explain how image is formed by lenses. Thank you.